Hello, good day, viewers. You're welcome to my class. So today we have a question to solve, which is under pH scale. So the question here is: a sodium hydroxide solution is prepared by dissolving 2.50 grams to make 2.00 liters of solution. We have to calculate the hydroxide and hydrogen ion concentration. So let's bring out the parameters we have. It says a sodium hydroxide. So these are some of the formulas we need to know under the pH scale. We have that hydrogen ion concentration is equals to 10 to the power of -5. We have another formula, which is hydrogen ion concentration multiplied by the hydroxide ion concentration. When you multiply them together, this is equals to 10 to the power of -14. We have another one which says pH plus POH is equals to 14. We have pH is equals to negative log of hydrogen ion concentration. And we also have the last formula which says POH is equals to negative log of hydrogen hydroxide. concentration. So now for this question, now let's bring out the parameters. We have the compound, which is what? Sodium hydroxide, right? That is NaOH. Say it's prepared by dissolving 2.50 grams. So that means the mass is 2.50 grams, right? It says to make 2.00 liter of the solution. What this means is the volume. 2.00 liter is the volume. So we are need to calculate the hydroxide concentration. So we are looking for OH minus concentration and also the hydrogen ion concentration, that is the H plus. So these are the two ones we have to find here. So looking at this, we need to calculate the molarity. And molarity, the formula for molarity is equal to the mass divided by the volume. So this will give us the value for the molarity. So the mass is given as 2.50 divided by the volume, which is 2.00. Okay? So 2.50 divided by 2.00 gives us a value of 1.25. So this is the molarity. So the unit mass is what? Gram. This is going to be, so what's going to be the unit here for the molarity? Oh, sorry, there's a mix-up here. The molarity is, the moles over the volume. Thank you for the correction. The moles over the volume. So for all those who are just joining my live, you're welcome. So the molarity is moles over volume, right? But here we don't have we have the volume, but we don't have the moles. So we have to find the moles. And for us to get the moles, we know that moles is equal to what? The mass divided by the what? The molar mass. We have the mass as 2.50 grams, right? But we do not have the molar mass of the compound, so we have to find the molar mass. So we need to get the molar mass of sodium hydroxide. So we know sodium is what? 23 plus oxygen here, which is 16, plus hydrogen, which is 1. So here we have 23 plus 16 plus 1. This gives us a total of what? 40 grams per mole. So that means we have the value for the molar mass of the compound. So we can come back here to substitute in the values. So this is equal to the mass. We have the mass as 2.50 divided by the molar mass, which we have gotten as 40. So this is 2.50 gram, and this is gram per mole, right? So we divide 2.50 by 40, and that gives us a value of 0.0625 moles. So this is the value for the moles. So remember, from the beginning of the solution, what we did first was we brought out the parameters. We have the unknown values, which we have to find, which is the hydroxide ion concentration and also the hydrogen ion concentration, right? So the next thing we did was to write out the formula for molarity, which is moles divided by the volume. So we did not have the value for the moles, right? So we had to come here to get the value for the moles. The formula for the moles is mass divided by the molar mass. We have the mass, but we do not have the value for the molar mass, so we got the molar mass here. That's the molar mass of the compound stated in the question, which is sodium hydroxide. So we're able to calculate the molar mass as 40 grams per mole. So after we got the molar mass, we came back here to the moles here and substituted the value for the molar mass and the mass. We divided and got the moles as 0.0625 moles, right? So now we are coming back now to the molarity, because we need the molarity to calculate the hydroxide ion concentration and also the hydrogen ion concentration. So now we can now substitute. So the molarity here will be equal to the moles, which we have got as 0.0625 divided by the volume, which is 2.00. So this one is in moles, while this is volume, right? So let's divide 0.0625 by 2.00. So punching our calculator, the molarity gave us a value of 0.03125. So this is going to be moles per volume. So let me write it this way. So the molarity is equal to 0.03125 moles per volume. So this is the value for the molarity. So viewers, hope you are clear up to this point. For those who had just joined my live, I welcome you all to my live session. Today we are calculating hydrogen ion concentration and hydroxide ion concentration. So if you have any questions so far up to this point, please kindly drop your questions in the comments. Let's see, so that we can move on from here. Okay. So if you have any question, kindly drop your question so we can move on. So I'll be in the comment section now if to see if there are any questions for further clarification before I move on. So we are yet to calculate the hydrogen ion concentration and the hydroxide ion concentration, right? So if you have any question, please kindly drop your question in the comments for those who are together with me. Okay, I'm in the comment section. Okay, so since there are no questions for now, so let's continue. So now that we've gotten the molarity, so now that we have the molarity, we need to write the reaction of the equation. Or instead, let's say equation of the reaction. Equation of the reaction. So this is sodium hydroxide. So this is going to what? Give us Na plus OH minus. So now let's calculate the hydroxide ion concentration. So we can use this last formula here, which says POH is equal to negative log concentration of the hydroxide ion concentration. So we can see that here we have just 1 mole of the hydroxide ion concentration. So that means here we're going to have that the POH is equal to the negative log. The concentration now is the molarity we have gotten, which is 0.03125. So we're going to punch our calculator to get this value. Okay, so we punch the negative log of 0.03125. So the calculator gave us a value of 1.05149978. So we can just approximate, and this POH here will give us a value of 1 point. Let's leave this as 1.51. So this is the value for the pH. Okay. But let's do it this way. Let me use another method. So I'll be in the comment section if there's any question.